Welcome to JPJ Discovery Channel for our new video. Where does the sun's heat come from? Today we'll follow the energy from the core out through the layers of the sun. The sun is a huge ball of gas and plasma, mostly hydrogen, about 92% by atoms. If the sun were smaller it would be like Jupiter, mostly hydrogen, but the sun's mass makes the core extremely dense and pressurized. At the core, high pressure forces hydrogen atoms to collide and fuse into helium. This nuclear fusion releases tremendous energy. Continual fusion heats the core to about 27 million degrees Fahrenheit, roughly 15 million degrees Celsius. Outside the core lies the radiative zone. Here energy travels by radiation. Photons are emitted and reabsorbed, taking a slow random path outward. Temperatures fall from about 7 million to 2 million degrees Celsius across the zone. A photon can take thousands of years to emerge from here. Beyond that lies the convective zone, where heat is moved by bubbling plasma, like boiling water. Hot plasma rises in bubbles, transports heat to the surface, then cools and sinks. Temperatures here are around 2 million degrees Celsius. The photosphere is the visible surface. Its light is what we see from Earth. Sunspots look dark because they are cooler, about 3,000 to 4,500 degrees Celsius. The photosphere emits most of the sun's visible light. Above the photosphere lies the chromosphere, hotter near the base, cooler higher up, and only a few hundred miles thick. Temperatures range roughly from 6,000 down to 4,000 degrees Celsius. Then we reach the corona, and things get surprising. The corona is the sun's outer atmosphere extending thousands of miles into space. Oddly, the corona reaches about 1–2 million degrees Celsius, hundreds of times hotter than the photosphere. Why is the upper atmosphere so much hotter than the surface? Scientists are still investigating. Leading ideas include wave heating and magnetic reconnection, but no definitive answer yet. In short, fusion in the core creates energy, radiation carries it outward through the radiative zone, convection brings heat to the surface, and complex magnetic processes heat the corona. Every 1.5 millionths of a second the sun releases more energy than humans use in a year. That energy travels outward as light, heat, and the solar wind that shapes space weather. Missions like NASA's Parker Solar Probe are traveling close to the sun to measure the corona directly. The probe samples particles and fields to test heating theories and the origin of the solar wind. Compared to other stars, the sun is a mid-temperature G-type star, not the hottest nor the coolest. Blue O-type stars can be tens of thousands of degrees hotter at their surfaces. Red M stars are much cooler. But for Earth, our sun's fusion-powered heat is precisely what makes life possible. If you enjoyed this explainer, subscribe for more space science and leave comments if you have any questions. Thanks for watching.